ENPP1 enzyme fulfills a critical role in the sense that it synthesizes or basically produces a molecule that is called pyrophosphate, which is also called inorganic pyrophosphate. It's generated by the cleavage of ATP by the ENPP1 enzyme. And that's what, when I refer to a kind of conserved in mammals, over really evolution. And so the role of pyrophosphate is to regulate mineralization, and you need maintain a certain level of pyrophosphate. So if you have too little, your calcification or mineralization will go unchecked. It will be too much. Okay. If you have too much pyrophosphate, your calcification or mineralization will not occur at all. It will be completely inhibited. If you have a loss of function mutation in the ENPP1 gene, and there are now hundreds of such mutations known, different, not all loss of function, some others, missense mutations, etc., you will therefore not properly produce the ENPP1 enzyme, and therefore you will also not form any pyrophosphate. This enzyme is really the only source that the body has, the only way that the body has to generate this pyrophosphate. So the patients present with what we call ENPP1 deficiency. They present with very low or non-detectable levels of pyrophosphate. And I will, in a short moment, explain what happens clinically. But what I do want to mention is there is a reason why people haven't heard about ENPP1 deficiency, and that is because, first of all, the disease manifests differently in different age groups because it affects you. You're obviously born with it. Yeah, it's kind of an inborn disease. It affects newborns and infants in its special way. It has high mortality. More than 50% of the infants do not survive. It then moves on to an adolescent phase where it's mostly growth, of course, and so growth is impaired. And if you reach adulthood, it has chronic long-term effects, and it has different names historically in the medical literature for each of these stages. So, for example, in infants, it's most widely known under the name of GACI, GACI, or generalized arterial, can't even say it, generalized arterial calcification of infancy. It's a very unwieldy name, so that's one. The second name that is used in the literature is IIAC, idiopathic infantile arterial calcification. Yeah, another unwieldy description. The third is I talked about the adolescents, the growing kids. There it's really called ARHR2, which is autosomal-recessive rickets type 2. And then in adults, really the disease will be described as osteomalacia. So we think it's been completely under-recognized for the reason that it's been differently named and differently diagnosed, and it's obviously also treated by different physicians. And oftentimes there is not a very good handover between the pediatricians or the neonatologists, even the pediatricians, and then the adult doctors or endocrinologists or whoever happens to be the treating physician. So I think that's very important to recognize. We believe this disease is much more frequently occurring and oftentimes not diagnosed. But let me describe, what happens. So I already said that PPI levels are very low. So these patients have limited quantities of pyrophosphate. This leads to excessive calcification. That's the first thing that you see in an infant, sometimes also already detected prenatally. The calcifications are occurring mostly in the vessels. So you will see aortic calcifications, cardiac calcifications. Those can show up on ultrasound. They will be giving a pretty strong signal on ultrasound. Sometimes it's suspected before birth. The child is born and then presents with oftentimes cardiovascular symptoms, with cardiovascular events, stress, hypoxia, shortness of breath, and so forth. So it will be relatively quickly detected because it's quite symptomatic and will point, even though this disease is so rare, will actually point in that direction because the combination of calcification, which you could then see on imaging technologies, and the cardiovascular effects is actually quite strikingly pointing into this direction. So we feel it's quite well diagnosed, at least, in the bigger, medical centers. Now, I told you that there's high mortality, but of course there are some patients that survive. That's a good thing. If they survive, they start developing, the typical symptoms of rickets, of longer-term symptoms that are then, the initial calcification has basically been survived, so to speak. Then the long-term effects set in, of this imbalance in mineralization. So you have disturbances in the skeleton, because the skeleton is, of course, the most important compartment, that needs to mineralize. That's actually the whole basis of this biological pathway, is to make sure that humans or mammals can form proper skeletons. And a skeleton, if you think about it, requires that it's formed only where you want it and does not calcify any of the soft tissues that we have. So that has to be highly controlled. So the skeleton can have dysplasias due to the wrong mineralization that usually leads to shortness, to rickets, to pain in the bones, and so forth. But you can have continued calcification in the soft tissue, because the soft tissue, the rest of the body can form calcifications the wrong place. And you see that. You could see continued vascular calcifications. You can see even cerebral effects, etc. You can see effects on the hearing, for example. Many of these patients don't hear because the very fine, organs that, are required for hearing are calcified, and disturbed. So I should also mention there is a downstream effect which relates to an additional critical metabolite, which is adenosine, that is formed in the same pathway. And as much as pyrophosphate is low, also adenosine will be low. And that lack of adenosine can have a second independent biological effect, which is too much proliferation of soft tissue, of cells in the vessels. So many of the patients with ENPP1 deficiency also have what is called intimal proliferation, or blocked vessels, and need, for example, to be stented with a metal stent that keeps the vessels open, which you normally would use in cardiac patients. But so that there are actually two important pathological events here: the calcification and the intimal proliferation. So it's basically a multi-organ disease to some extent, but with a strong component on initially the calcification in infants, leading to mortality through cardiovascular events, and then skeletal defects, mostly the ones that are visible in the adolescents, with the rickets legs and the shortness, and then in adulthood it's just more of the chronic effects that are caused by lifelong, ENPP1 deficiency. That's what we, bone pain, fractures can occur as well, fatigue. It's presenting similarly as XLH, or X-linked hypophosphatemic rickets, which is a related but nevertheless different type of rickets. Yeah. So.